Okay, today we are solving systems of equations by graphing. So our question is, how do we do that? How do I solve a system of equations by graphing? So one of the first things that we need to talk about as far as what that means to solve a solution for graphing a solution is a point xy that makes all equations in the system true. And we'll discuss what that means further. But that's what it means by solve. How do I find the point that works for all the solutions, or for all the equations in this system? So we start by, when you're given two systems, we have to rearrange the equations into slope-intercept form. Because that's the easiest way to graph, which is y equals mx plus b. So that I can find the slope and the intercept and be able to graph them. Then we graph both, because we're only working with systems that are two equations, so you have to graph both of them on the same graph. So they will probably overlap at some point. Then the solution is the point where the lines intersect. Oops, I don't know what that just was. Intersect. Remember that it is a point xy. A system can have one of three types of solutions. It can have one when lines intersect. So that's just one point. It can have none or no solution when the lines are parallel. They're never going to touch. And it can have infinite. This is the symbol for infinite. When the lines are the same. So we talked about this in another note page, but 3x plus 2y equals 6. 6x plus 4y equals 12. Those are the same line. And so that would be an example of infinite solutions. So here's an example where we're going to graph these two equations on the line. So the first step is to look at them. Are they already in mx plus b form? Well, one of them is. So this one I can do. This is the yes. So I can pull out that the slope is 1 over 1, and I can put that the intercept is the point 0, 1. So then we come down here, and we're going to graph that equation. So starting at 0, 1, up 1, right 1. And here is line 1. So then we look at this equation, and this one's a no. So I need to get it that way. So we start with x minus 3y equals negative 9. We subtract x from both sides. Negative 3y equals negative x minus 9. divide by -3, and I get y equals 1 over 3x plus 3, where my slope is 1 over 3, and my intercept is the point 0, 3. So I'm going to graph that one, 1, 2, 3, here's that one, and I'm going to go up 1, right 3, and so there is that line. So then when I graph that line, and that's pretty close, here's line 2, and here's line 1. We want to locate the point of intersection. If you look, you can see right here where the point intersects. And that is the point 4, nope, I did it backwards, 3, 4. Because we go over 3 and up 4. So then I have to check the solution. We've done several checks, but I want you to see that this is important because I could have graphed it incorrectly. And so I need to make sure that this point right here is in fact the solution to both equations. So let's start with the first equation, which is y equals x plus 1. Instead of y, we put 4 equals. Instead of x, we put 3. 4 equals 4. Sure does. That checks. Then we take the other equation, which is x minus 3y equals 9. X is 3 minus -9, sorry. 3 times 4 equals 9, -9. 3 minus 12 equals -9. -9 is -9, and that checks. So our solution actually is 3, 4. The checking part is not optional. You must, when showing your work, show me that you checked your solutions. All right, so let's look at some other ones. Starting with y equals 8x minus 1. So the slope is 8 over 1, and the intercept is the point 0, -1. So that one, I don't have to do anything other than graph the equation. So 0, -1, and we're going to go up 8, 7 over 1, so right there. So get our line drawn here. So there's line 1. And for line 2, I have to put it in slope-intercept form. It currently is not. So I'm going to add 16x to both sides. 2y equals 16x minus 2. Divide. And I end up with y equals 8x minus 1, where my slope is 8 over 1, and the intercept is 0, -1. So when I graph that, you should notice that these two things are the same. So what's that going to tell us about the line as we graph? So I go 0, -1, and then I go up 8, down, or right 1, and so that when I graph, the lines are on top of each other. They are the same line. That means that I have infinite solutions. Let's look at another one. Here we have x equals -4. So these kind of lines are tricky, but we need to figure out how to graph that. So here's the x. This is the x-axis right here. So that's where I'm going to go. And where is x -4? Right here. Where else is x -4? Well, not sideways, because that's -5, and that's not the same thing. So that tells me that x equals -4 is a vertical line. Vertical lines have undefined slope. And it intersects the x-axis, which is what this means, at 0, -4. Notice that this is an A, not a B. The second equation needs us to rearrange it. So we're going to subtract 3x from both sides. Divide by -2. And I get y equals 3/2x plus 3, where my slope is 3/2 and my intercept is 0, 3. So that when I graph over 0, up 3, right 2, I'm going to undo that. I don't like that line. Down 3, right 2, down 3, right 2. So what's the name of this point where the lines intersect? So the solution is -4, -3. -4, -3. And I wrote this one backwards. This should be -4, 0. So that when I plug this solution into my equations, when I plug this solution into this equation up here, is x -4? Yes, x is -4. Into this second equation, when I have 3 times -4 minus 2 times -3 equals -6. -12 plus 6 is -6. -6 is -6. Check. That's the solution. It is also one solution. I will not have another one. That's the only place those two lines will intersect. So now let's look at another one. So we start with the line y equals 9. So y equals 9 is a horizontal line right here. So the slope is 0 and the intercept is 0, 9, where y is 9. The next one isn't in slope-intercept form, so I have to subtract to get it in there. Y equals -6x minus 9, but I only had to do one step. So that my slope is -6/1, and my intercept is 0, -9. So when I go to graph this one's a little hard, because here's my point 0, -9. How can I go down 6 and write 1? Because this means right now, down 6 and write 1. But if I go up 6 and left 1, isn't that the same thing? 6 over negative 1 is the same thing as negative 6 over 1 because of signs. So then I can count up 6, 1, 2, 3, 4, 5, 6 over 1. 1, 2, 3, 4, 5, 6 over 1. 1, 2, 3, 4, 5, 6 over 1. It is best to plot as many points as you have to until they intersect, because if you don't, you might miss it, especially when you're graphing. Remember, we're going for precision here, and that's how we achieve that. That was really crooked. Okay, so then I got to identify the name of this point, and that appears to be 9, negative 3. Sorry, negative 3, 9. Doing it backwards because I went over 3 and down 1. And so, again, that's one solution. For number 4, the first equation is in slope-intercept form, so that one's not too bad. Oh wait, I forgot to substitute. So here's my point. I need to make sure it works. 6 times negative 3 plus 9 equals negative 9. Negative 18 plus 9 equals negative 9. Negative 9 is negative 9. That's true. And then when I put negative 3, 9 into this equation, does y equal 9? Yes, 9 equals 9. So then I have 9 equals 9 because 9 is y, and that's also true. So that's how I know that I've solved my system correctly. So let's look at number 4. This is already in slope-intercept form, so I know that my slope is negative 1 over 1, and my intercept is 0, 3. So 0, 3, and then I'm just going to do a couple to get it going, and then I can graph on my grid. Oops. Without erasing. So there's the first line. The second one, of course, is not in anything that we can graph easily, so we got to put it in slope-intercept form. So subtract the x from both sides. Negative 6y equals negative 4x plus 12. Divide. Y equals 2 over 3x minus 2, where my slope is 2 over 3 and my intercept is 0, negative 2. So 0, negative 2 is where I start. Up to right 3. I did it a couple times just for accuracy's sake. But you can see that right here is my intersection. And so the name of that point is 3, 0. And again, one solution. Now I want to go verify that, so I'm going to plug it into both of my equations. Y is 0, so if I have 0 equals negative 3 plus 3, 0 equals 0, that's checks for this one. For this equation, 4 times 3 minus 6 times 0 equals 12. 12 equals 12, check, it does. So that is in fact the solution for that system of equations. Take a minute and write down step by step how to solve those systems of equations by graphing, what you need to do. Go back and restate the first couple lines of the notes so that you can feel confident in your understanding of how to solve a system of equations by graphing.